Okay, looks like, okay, it's 1 o'clock. Let's get started. Welcome to this week's HDF clinic. Last week we had an ECP event, and so we skipped that, but now we are back in full force. I checked the Google document earlier. There weren't any questions, but for anybody who is here today, are there any questions right now? Then now is the time to speak up. We will have more rounds, but otherwise, if there are no questions, I'll just continue. But if you have a question, please introduce yourself and ask a question. Okay, there aren't any right now, which is fine. Let's just continue. Let's talk a little bit about last week's highlights, and we always start with announcements. Number one, we actually today, as we speak here, there is an event going on in Europe called Meet C++ Online Tool Fair. And in case you missed the announcement on the forum, there is a presentation about H5CPP. So if you are interested in C++ and using HDF5 with C++, I would say that's a must-see, and I encourage you to, after this meeting, to head over there. And so it's, I'm sure it's going to be interesting. Stephen Barker, the author of H5CPP, is going to be there and answer questions and talk about H5CPP. Another event that's coming up is part 2 of our HDF application tuning webinar. It's been posted on the forum. I believe it's on April the 30th at 11 in the morning, 11 a.m. Central Time. And this time it's about HDF5 library performance variability. So getting poor performance is not always your fault or your application's fault. Sometimes it's just the way, maybe how your application interacts with, or purely the HDF5 library's fault. And so we'll talk more about that during that webinar. Another webinar that's coming up in May is about H5 Coro, cloud optimized read-only library for HDF5. If you are interested in using HDF5 in a cloud, in a public cloud like AWS and the S3 object store, then that might be for you. I think our speaker is from NASA, and so they have plenty of use cases with HDF5 and public clouds, including AWS. And I encourage you to tune in for more about that. And then finally, we have our ongoing call for papers, or paper and presentation, or presentation only event out there for the 2021 HDF users group. And yeah, deadline for abstracts remains June 1st, and then the actual event happening mid-October. Okay, I'm going to pause here. Maybe there are any questions about that or any other thing related to HDF5. If you have a question, speak up. Otherwise, I'll just continue. Okay. Let's talk a little bit. There's been a lot of activity on the forum. I sort of made my choices here, but if you want to talk about another issue specifically, bring it up and we'll look into that. I sort of pick what caught my attention, so it's subjective. There was a little bit of progress on this issue where a user was doing parallel HDF5 writing of just a one-dimensional array or one-dimensional distributed data set. So this is in parallel. And he had issues with the Darshan HDF5 module, as it now turns out. if you look at the conversation, the thread, I replied earlier in the week, I was able to, I think, reproduce an issue that he is seeing, or something related to the issue that he is seeing. What is basically happening, I was able to take my example program that has sort of this characteristic that different MPI ranks write different amounts of data to the same chunk data set in parallel. Some of the ranks in my example, the odd ranks, so ranks 1, 3, 5, and so forth, don't write any data at all. And then the even ranks write different amounts of data. So if I take this application and build the latest version of Darshan 3.2.1 with MPI, with OpenMPI 4.1 in my case, and HDF5 1.10.7, everything is fine. I can just LD preload the Darshan library, run it, get a Darshan profile, everything looks good. However, when I build the Darshan library with, there is a configure flag called -- I believe it's called enable HDF5 or something like that. That's specifically there to get more HDF5 specific profiling information for HDF5 in Darshan. Then if I LD preload that library, creating the profile actually fails, and the error message that I'm getting is interestingly an HDF5 error message that basically says, well, there is an irregular hyperslab selection, or this is not a regular hyperslab selection, I believe. I pasted the error message in the forum, and which is true because again, the odd ranks do not write any data at all, and the way to achieve that is to basically say there is an H5S select none call, and so I do an H5S select none, and that tells HDF5 there's nothing to see here, nothing to write here, so just focus on the processes that have to write something. However, it appears, and H5S select none in the HDF terminology obviously is not what we call a regular hyperslab selection, where you have a pattern of sort of start, stride, count, block. H5S select none is just sort of a special case, a corner case, and it's not a hyperslab selection. What's not clear to me though is why this error gets triggered by Darshan, but I would imagine that, yeah, the Darshan module, when intercepting HDF5 calls, somehow accepts or expects there to be a regular hyperslab selection, and that gets tripped somehow here, and that's why we see this error message. But yeah, the user said that he will ask a question on the Darshan mailing list and see where we are. Interesting enough, he posted the error that he is seeing, and I believe, if I remember correctly, he saw some kind of floating point exception, which sounds completely outlandish in this context. But I think it's one more data point that maybe there's something going on here in the Darshan module. And so if that's a thread of interest to you, keep watching, and we'll keep you up to date. Any question? Otherwise, I'll continue. Is there any question about this topic or any other topic related to HDF5 forum, not forum, doesn't matter, documentation? Any questions? No? Okay, I'll continue. Okay, so the title here is a little bit misleading, but this is also another ongoing conversation where a user described his setup, acquiring some kind of camera data, but also sensor recording and things like that. And where the discussion stands right now, initially, the nice thing about this thread is that this user was so kind to actually post some call them little architecture diagrams of how he thinks to sort of orchestrate and arrange his data acquisition. And so we are now talking about sort of his life cycle, and that's the important thing, is if you really, well, number one is that you take the time for planning. If you unless you are doing a one-off and you're just a student who does a master's thesis, that's not no excuse to say that somehow students are encouraged to do a sloppy job or something like that, but you have other things to worry about. So we cut you some slack there. But if you're designing something and it's not just for yourself, it's not your hobby, it's sort of for production use and so forth, and there is a data life cycle that has to do with acquiring the data, pre-processing the data, analyzing the data, potentially creating data products, and then who knows, in a distant future, someone reusing the data being archived and so forth. I think it's good to start planning and thinking very early and really think things through. And I think this is what this user is doing, and that's great. If you then do that exercise, what you will quickly realize is that there are competing requirements in different phases, in different stages of your data life cycle. You will have different priorities. You will use different tools. Some of them may know about HDF5, some of them don't, and then you have to plan for that and test for that sometimes in advance, just to be sure that things work out. And what I would also say is, of course, there is a tremendous amount of primitives and features and whatnot in HDF5, and there are frequently situations where, and if you follow this thread, there are many different ways how you can do one thing in HDF5. So for example, on the one hand, you would prefer a single file, but then if you have very high data acquisition rates, then sometimes maybe one file, at least for the actual acquisition stage, is not a good solution. You want to spread potentially the load across multiple files, but then of course, for the analysis and other stages in the data life cycle, you would like to give applications a logical view of a single file. And then there are different ways to achieve that. But then it's also, you will have multiple data sets, but then again, in the interest of simplifying matters for clients, you would sometimes like to bring all those individual data sets together and view them as one large logical data sets. And there are pros and cons either way. And it also depends on what you are trying to achieve. So if you have multiple recordings, if you never look across multiple recordings, well, then creating that logical view of the single data set is probably not that helpful. But then if that's one of your goals, well, yeah, then the number of candidates or the number of implementation options shrinks, and then you have to be sure that that is such an overriding concern that it drives decisions that you make in the design of how you lay things out in one or more HDF5 files. But it's a process, and I think you're better off if you take the time. And then finally, yeah, there's always things go wrong, even with the best plans and the best designs. And then it's down to robustness in terms of doing the error handling, taking precautions, certainly inside of HDF5, but also around. And yeah, just think it through, plan it through. So this is a good example. Maybe we don't talk often enough about, and it's kind of, on the one hand, it's understandable because it's difficult to generalize from specific set of circumstances to other circumstances, but then nobody loses for sure if people could find a way to exchange sort of the practices and ideas and so forth. So that's an interesting one. I'm going to pause here. Are there any other questions around this or anything else? HDF5, that's fine. No? Okay, then I'm going to continue. There's another interesting issue out there. A user is sort of running out of resources, and of course you start with the simple things, and our initial because it's typical in situations like this is that people do not necessarily follow the discipline, the handle discipline. And so, of course, when you open a data set or you open a file and so forth, HDF creates resources, but it will release those resources only if you then at some point consciously and deliberately release those resources with the corresponding close call, href close, href close, and so forth. And especially, if you have a long-running application, you do things in a loop and iterations. It's a common problem that sometimes people aren't aware of when they make a call that returns one of these handles, one of these HID_T type things, that then kind of the responsibility or the ownership is on them to ensure that these handles get properly closed and so forth. And yeah, if you have an application that's running for days, a few bytes or a few kilobytes here and there may not matter if your application runs for half an hour, and you may never notice. But yeah, in this case, I believe the application runs for days. And then, yeah, unfortunately, I think in this case, it runs on a 32-bit system, so where you are more constrained as far as RAM is concerned anyway. And so, yeah, we have to look into what's happening there. There are some library means to check on open handles, although not all kinds of handles. So the typical object handles, the data sets, the named data types, the groups, and the files. But I believe for attributes and data spaces and things like that, I think there is no call that would cover those handles. So that's unfortunate. But then, of course, you can look at external tools like Valgrind, for example, that will tell you if there are suspected memory leaks. You can look at a Valgrind trace, and then a colleague of mine pointed out there is actually a call called H5 free list size, I believe, where you can influence how much space the library sets aside for free list management. And so free list management around your open handles and so forth. And so maybe that helps. I saw the user actually posted a code sample. I saw that he or she actually is already clamping down on the metadata cache, so that it appears that I think there were at least dozens, if not hundreds, data sets open at the same time, which is fine. As long as you adhere to that handle discipline, that's perfectly fine. But the user was sort of trying to control the metadata cache footprint or the chunk cache. I forgot if it, I think it was the chunk cache or the meta. I believe it was the metadata cache. No, the chunk cache. The chunk cache to reduce that size and say, don't bother. I'm tight on RAM, but still, so we will see what comes of that. But it's certainly interesting to see, and yeah, hopefully we can find a solution. Okay, that was that. I'm going to pause here. Is there a question about this or anything else? HDF5? No? Okay, then I'll continue on. This is a question where unfortunately I don't have an answer. Is somebody tries to call the Fortran version of C++, the Fortran version of H5D write.
Hey, Gerd, I lost audio.
With the Fortran compiler from C++, because at the end of the day, the linker will tell you what symbols are there and in your object file, and you can link to those symbols, and that's all good. As far as I recall, of course, the calling convention in Fortran is that everything has to be passed as a pointer. So even you might have an integer argument, but you still have to pass that integer argument through a pointer to that integer argument. But that's about it. So there might be more to this, and of course, not all. Unfortunately, not all arguments in H5D write, especially. I mean, you have the memory space selection. You have data type arguments, you have a data set transfer property list, and then the buffer itself. So there are quite a few arguments, and some of which are passed by pointer already. But then, to be honest, I don't really know if an argument is already a pointer to a struct, let's say. Do you have to then pass a pointer to that pointer, or is it good enough to pass the pointer? So, but that's where we hope that somebody in the community who is an expert there can chime in, because it has nothing to do with HDF5 at this point. It's really just a matter of calling conventions and interoperability, so to speak. But you might ask, that's maybe a good one, you might ask, well, why would anybody write in their mind call the Fortran version of H5D write from C++? Well, a reason I could see is that if you, depending on how your data was written, one of the differences, of course, as far as multidimensional arrays are concerned, is that whether they get written row major or column major, so which array dimension is sort of the fastest running dimension in your multidimensional array, and then sort of hierarchically down, because the HDF5 library will write the data as presented to it in memory. The HDF5 library will not touch your data. It will not transpose or not do anything to that data. So for example, in this case, if you know, for example, that the application that originally created the data used that column major, that Fortran call it that convention, but I believe also Julia and some of these other systems also have a column major convention. Then in order to get the data that you expect, or in this case, it's actually a write call, not a read call, but it applies the same way. If you want the data to be written in column major form on disk, then it makes perfect sense to call the Fortran write routine. But again, unfortunately, nobody has replied so far. I'm sure there's somebody out there that knows that, and maybe the user who asked that question figured it out himself or herself already. Okay, that was a good one. We have about 5 minutes left. Any questions? Any questions related to HDF5, related to these issues? No? Okay, then I will just continue. So on today's tips, tricks, and insights, and I hope you will expand on that. As I said the last time, Quincy had that great idea. Since there are things changing with asynchronous calls and so forth, it's always an interesting question, what happens to handles and IDs and so forth when your program ends? And if you have topics of interest that you want us to cover here in this brief format, you can leave a comment in the Google document or send a message through the forum or something like that, and we'll pick it up. So today I picked this call. There is a call in the sort of file access property list category. It's called H5P set F close degree. And just as a pun, I said, do you really need a degree to use that call? The answer is no. It's actually pretty clear, or relatively easy to describe. What that call does is, so let's recap these HIDTs, these handles. They are just sort of, they are transient, so which means they are not persisted in the file. They really exist only in memory at runtime. And they will be also different every time you run your program. So in the 64-bit versions of the library, 110 and later, there are 64-bit integers, signed 64-bit integers. So if you want to, you can do a printf on one of these HIDTs. But what will most likely happen is if you run your application at different times and you open the same data set, there's a good chance that the integer, or the long integer in this case, will be different many times. So it's transient, it's runtime only, and you shouldn't really read into it other than as a vehicle of interacting, managing that object or that resource. And of course, everything typically begins with you create a file or you open a file, and that will give you a file handle. So that will be one of those HIDTs that you get from H5F create or H5 open. But then in addition to that, an empty HDF5 file is kind of boring or not very useful. What happens to these other handles that you will create? That you will create groups, you will create data sets, or if you have an existing HDF5 file, you will open groups, you will open data sets and so forth, make selections on these data sets and so forth. So what happens, for example, if for some reason, unbeknownst to you or intentionally, it really depends, you close the file, but all these handles, these open handles that have not been closed, no matching close call, H5S close, H5A close, and so forth, has been issued. What happens? And to make things worse, there are other things that could be going in the file. There's, for example, a call called H5F reopen. You can reopen the same file. You can mount other HDF5 files in groups in an HDF5 file. You can have external links that, as a side effect, when you traverse these links, will actually open other files and so forth. What happens to all of that? And that's what this close degree is for, where you have basically 3 values and then a default. You can have what we call a weak close degree behavior, where if the file, if you are in this mode and you close the file, then that handle, that HIDT, will be marked as invalid, and trying to use it in the future will not succeed. However, if there are existing open file handles, those will continue to work, and only once the last of them is closed will the HDF5 library actually close that file and sort of shut down. The next option is semi, where you basically, with weak, you are sort of taking the position, well, there could be something going on in my code, and but just in the interest of, I might close the file, but there might be other objects out there, and I just want to make sure that ultimately everything gets closed. but I don't want an error. In the case of semi, you would be saying, well, if there are other open things remaining, then I want to know that, and I want to receive an error. If I try to close the file and there are remaining open handles, then this would give you an error. And then finally, if you want to be sort of rather draconic and deliberate about it, you would say, well, when I close the file, please go ahead and close all these other things, whatever that may entail, and shut everything down. And then the default is really typically the virtual file driver, the POSIX and others that you use might be deciding what's used. And for most VFDs like POSIX and so forth, it's that weak scenario. Notable exception is MPI-IO, which uses semi, so you will definitely get an error message if you close the file and there are other open file handles. So really not that difficult, but I think useful to know. And time is up, 1:30. Thanks everybody for coming. Come back next time, ask questions, and yeah, we'll be in touch. Thank you. Bye.